So number 38, we're told an object is located 20 centimeters to the left. So P is equal to 20 centimeters to the left of a diverging lens having a focal length of negative 32 centimeters. Negative 32 centimeters. And diverging lens means that we have a focal length less than 0. So that's why we have negative 32. We're asked to determine the location and the magnification of the image. So we want Q and we want M. For C, we want a ray diagram. All right, solving for Q is pretty straightforward. We just plug it into our formula. 1 over Q plus 1 over P. And we're solving for Q, which means that 1 over Q is equal to 1 over F minus 1 over P, which if you go through the algebra, which I've done several times up to this point, you actually get that Q is equal to P times F over P minus F. Okay, and we just plug in the formula, negative 32 centimeters times P, which is 20 centimeters, over 20 centimeters minus negative 32 centimeters, because this is P minus F, right? Well, if we plug this into a calculator, we get negative, I got that there, negative 12.3 centimeters. That's what it comes out to. Okay, that's Q. So Q is negative 12.3 centimeters. So that's fairly straightforward. And it's important to note that because we're told this is a diverging lens, which means that the, like whatever the shape is, if it's this way or if it's out. The point is, typically we're going to have wider edges. It's going to cause it to diverge. And so if we have this kind of lens, this negative value is going to mean that it's actually in front. So the image is actually in front of the mirror. So here is P, here's Q. Okay, just something worth knowing. And so then when you find magnification, negative 12.3 centimeters over 20 centimeters. This is going to give us a value of 0.62. So what that means that this is going to get smaller, the image gets smaller, or shorter, if you can say. And because it's a positive value, m greater than 0, for our diverging lens, means that it's virtual. Sorry. I don't know why I wrote that. Upright. It means that it's upright. And like I said before, it's in front. So it's upright and it's in front. The image is upright and it's in front of the mirror. So there's a table in the book. Let's see, what is it? 23.3 table. 23.3, and that's where you can find a lot of this information, such as this is going to end up in front. So putting all of this together, we have our focal length, which was 32 centimeters away. We had our point P of the actual object. We had our object here, which was 20 centimeters away. And then we had our image, which was, I think it was 12.3 centimeters away. So we have our mirror, something like that. So note that I made this shorter than this, so the image is shorter than the object itself. We found that out by looking at the magnification. Okay, so now we're going to draw our ray diagram. So let's say this is going to go that way, and then also it's going to intersect here like this. And then we have our focal length. Okay, so this is what our ray diagram would look like. I think that should do it. Right, we have the image, we have the object, and we have our focal point. Okay, good. Next problem. Number 48. A real object's distance from a converging lens is 5 times the focal length. Magnification is equal to... Oops, nope, that's not right. Sorry, misread that. A real object's distance from a converging lens is 5 times the focal length. So the distance from the lens is 5 times f, right? Determine the location of the image q in terms of the focal length. So we want q. It's going to be in terms of f. It's a function, right? We want to find, that's going to be part A. Part B is find m. C, we want to describe the image, right? Is it upright, virtual, inverted, real, these types of things? Is it on, which side of the lens is it on? So we want to describe the image. Okay, so using our formula that we have solved for Q a bunch of times up to this point, we have P times F over P minus F. P is 5 times F. 5F times F over 5F minus F. 5F squared over 4F. 5/4 times F. That's Q. Okay, so now M is going to be negative Q over P. Negative 5/4, negative 5 over 4 F times 1 over P, which is 1 over 5F. That's going to give us, these are going to cancel, right? Negative 1 over 4. So the image is going to be smaller than the object, and because it's negative, it's inverted. Noting that Q, in this case, we're told it is a converging lens, right? So for a converging lens, f is greater than 0. So for Q is equal to 5/4 f, that's greater than 0 as well. So for Q greater than 0, that means that we have a real image. Okay, so we have a real inverted image. Now we want to, so I'm already on part C, right? We solved for Q, we solved for M, which is negative 1/4, and now we're describing it. So it's real, it's inverted, and looking at the table for lenses, noting that a Q with a value greater than 0 is going to put it behind the lens, so this is going to be behind the lens. So that's everything we were asked to do for that problem.